Okay, this is chapter 16, lesson 7. So lesson 16.7, the last lesson of the entire book. It starts on page 750 if you're following along in your textbook. And it starts by saying to add or subtract numbers written in scientific notation with the same power of 10, add or subtract the factors. When the numbers have different powers of 10, you have to rewrite the factors or the numbers so they do have the same power of 10. So let's look at example 1 here, part A. They have 4.6 times 10 to the third plus 8.72 times 10 to the third. Oh, well, that's nice. Same power of 10. So you just add the factors. 4.6, 8.72, and 13.32. So you have 13.32, and the power of 10 stays the same, times 10 to the third. Well, the only problem here is it's no longer written in scientific notation because this needs only one number in front of the decimal. It's got 2. So we're going to just move that decimal one spot. Because that makes this factor smaller, we need to make this factor larger. We moved it one spot, so 1 power of 10. We'll make this larger by 1 power of 10. So the answer is 1.332 times 10 to the 4th power, which is what they came up with. Isn't that so smart of them? And then example 1b. We start with 3.5 times 10 to the negative 2nd power, and we're going to subtract 6.6 times 10 to the negative 3rd power. So now we do have where there are different powers of 10. So we have to switch. We can either switch this so it's to the negative 3rd or switch this so it's to the negative 2nd. If you look through the example, they chose to rewrite this one, so it was to the power of negative 2. And you can look through their example for that. We'll do it the other way, just so you can see it both ways. So if we're going to make this to the power of negative 3, we made this smaller by 1 power of 10. So we're going to have to make this larger by 1 power of 10. There we go. So now we have 35 times 10 to the negative 3. And subtract 6.6 times 10 to the negative 3. Well, now we have the same power of 10. It's a subtraction problem, so we'll subtract these two. 35 minus 6.6, lining up the decimals, of course. So we have this and that and this and that and this, 28.4. So 28.4 times 10, and we keep that power of 10, to the negative 3. Once again, it's no longer written in scientific notation. It's a quick fix. We'll make this smaller by 1 power of 10. So we'll make this larger by 1 power of 10, and we get 2.84 times 10 to the negative 2nd power, which is what they came up with. Good for them. Now we've got some on your own problems. For number 1 on your own, we have 8.2 times 10 to the 2nd plus 3.41 times 10 to the negative 1st power. So we have to change them so they have the same power of 10, and we'll go and we'll make this one smaller. So if we're going to make this smaller, we have to make it smaller 3 times. So we have to move this decimal 3 places to make this part bigger. So 8, 1, 2, 3, moving it 1, 2, 3 places. That will make this times 10 to the negative 1. This got bigger by 3 places of 10. This got smaller by 3 places of 10. Plus 3.41 times 10 to the negative 1. So we'll add the two factors. So we have 8,200 plus 3.41. Important to line up the decimals as usual. And we'll get 8,203 0.41. And then we have to keep that power of 10. So we have 8203.41 times 10 to the negative first. Well, we do have to make this smaller by 1, 2, 3 places. So we'll make this bigger by 3 places. And we'll get 8.20341, all important digits, times 10 to the, make this bigger by 3 places. So it goes up to 0, up to 1, up to 2, to the second power. Yeah. Number 2. 7.8 times 10 to the negative fifth power minus 4.5 times 10 to the negative fifth power. Oh, how kind of them. Same power of 10. So we just have to subtract these two. 7.8 minus 4.5, and we get 3.3. 3.3 times 10 to the negative 5, and it is in scientific notation. Oh, that problem was easy all around. Yay. So now we look at example 2, where they're talking about multiplying numbers in scientific notation. And it says to multiply or divide numbers written in scientific notation, multiply or divide the factors and powers of 10 separately. Okay, well, let's take a look here. For example 2, they have 3 times 10 to the negative fifth times 5 times 10 to the negative second. And since it's all multiplication, we're just going to multiply these two things right here and get 15. And remember, when we're multiplying the same base to different powers, what we do is we add these powers. So negative 5 plus negative 2 gives us negative 7. So 15 times 10 to the negative 7th power. Not in scientific notation anymore. So we'll make this smaller by 1 spot to make it 1.5. And we'll make this bigger by 1 spot to make it 10 to the negative 6. 1.5 times 10 to the negative 6. Then let's look at a division problem. For their example, they give us 1.5 times 10 to the negative 8th power divided by 6 times 10 to the 7th power. Well, we'll do this 1.5 divided by 6 first. 1.5 divided by 6. 6 goes into 15 twice, which is 12. 3. 6 goes into 35 times, which is 30. So 0.25 times 10 to the, and when we're dividing these, we remember we subtract. So negative 8 minus 7 would give us negative 15. Negative 15. All right, so now not in scientific notation. We'll make this larger over on this side. So we make this smaller by 1 on this side. And we get 2.5 times 10 to the negative 16th power. And now let's look at the on your own problems for this. Number 3, 6 times 8 times 10 to the negative 15. Nope, to the negative 5th, sorry. To the negative 5th. Well, we can multiply these in any order we want. Remember, this would be 6 times 10 to the 0th power, because that's 1. But we'll just multiply. We only have 3 factors here. 6 times 8 is 48. And we'll just keep this factor times 10 to the negative 5th. Not in scientific notation, though. So we make this smaller by 1, 4.8. So we make this bigger by 1, times 10 to the negative 4th. 4.8 times 10 to the negative 4th. Number 4, we have 7 times 10 to the 2nd power times 3 times 10 to the 5th power. So we multiply the two factors. 7 times 3 is 21. And 10 to the 2nd times 10 to the 5th, we add the exponents and we get 10 to the 7th. We do have to make this smaller by 1. So 2.1. So we make this bigger by 1 times 10 to the 8th. 2.1 times 10 to the 8th power. Number 5, we have 9.2 times 10 to the 12th divided by 4.6. Well, 9.2 divided by 4.6, we'll do that first. 9.2, 4.6. Move the decimal one spot, move the decimal one spot, makes this problem now 92 divided by 46. Well, 46 goes into 92 2 times, which is 92, which is also nice. So it's 2, and then we'll divide the powers of 10. So 10 to the 12th power, and then this would be 10 to the 0th power. We'd subtract them. That's not going to do anything. So we'll just have 2 times 10 to the 12th power. That's already in scientific notation, so we're done with that one. And finally, number 6, we have 1.5 times 10 to the negative 3rd power divided by 7.5 times 10 to the 2nd power. So we'll do the division of these factors first. 1.5 divided by 7.5, so 1.5 in the box, 7.5 out of the box. Moving the decimal one spot, we have 15 divided by 75. Annex is 0, and 75 goes into 150 2 times, which is 150. So 0.2, and now we're dividing these. 10 to the negative 3rd divided by 10 to the 2nd. If you want to write it like this, 10 to the negative 3rd over 10 to the 2nd, that might help. But we are just subtracting these two, or you can think about it this way. Remember, if you're going to bring that up top here, this would have to turn into 10 to the negative 2nd. Putting a negative on there. Now you add those two. Any way you do it, you're going to get times 10 to the negative 5th. You could either bring that up here, just do your subtraction like that. 0.2 times 10 to the negative 5th, not in scientific notation. We do have to make this larger by 1 spot, making it a 2. So we'll make this smaller by 1 spot, making it a 10 to the negative 6. And 2 times 10 to the negative 6 is in scientific notation. Excellent. Well, you should be able to go and do journal page 394 now and answer the questions. See ya.